Section 8.3, scale diagrams. So this section might be a little difficult because I can't demonstrate that well over a video how to actually draw this and take out a ruler. But you are going to be needing to use rulers and drawing things in this section. Okay, let's look at this example. Maxine is moving into a new apartment. Before moving day, she wants to decide where to place her furniture in her new living room. When she visited the apartment, she drew this rough sketch of what it would look like. Okay, she has also measured her large furniture, which she wants to place. So she wants the movers to do it. She's a smart woman. She wants them to do it. These measurements are shown in the table below. So how can you use a scale diagram of this room on an 8.5 inch by 11 sheet of paper to determine where to place these pieces of furniture? We need to determine a scale, and a scale is the ratio of the measurement on a diagram to the corresponding distance on the shape measured on the object. So it's the diagram to the object, that's your scale. So we need a scale we can use to create a scale diagram on an 8.5 by 11 inch paper. So we need some scale that's going to fit these measurements. It's not going to be teeny tiny or too big. We have to figure out a scale. Okay, and the process we're going to do that is we're going to say if we made 10 feet as 120 inches, so we went 12 times 10 is 120 inches. If I use the scale of 1 to 12 rather, the scale diagram would not fit on the paper because then the wall would need to be 10 inches wide, and I only have an 8.5 by 11. Okay, and remember this is 10 feet, and I still have this 9 feet over here, so that wouldn't quite work, plus the balcony. Okay, so that's not going to work. So then the next most convenient is going to be half that, 1 to 24. Using the scale diagram would fit on the paper. Also, using the scale to determine the measurements for the living room would require only simple mental math. Dividing each measurement in feet by 2 would give the measurement on this diagram in inches. Okay? Question B. Use your scale to determine the lengths of the walls and openings. Okay, so if this is 10 feet, if I divide that by 2, that means this is going to be 5 inches. If this is 9 feet, 9 divided by 2, this would be 4.5 inches on my scale diagram. This would be 1 inch, 1 inch, 2 inches, 8 divided by 2, this would be 4 inches. This 5 feet would be 2.5 inches, and then I would just connect that line. Okay, so let's see if that's what they did. Yep, 5 inches, 4.5, 1, 1. Not too bad. And their balcony was just rough. Okay, so this is something where you would actually have to get out your ruler and draw this. And that's the neat thing about scale diagrams. It's not guessing. You're actually going to draw it. So if you choose a scale factor that is too big or too small, you're going to see it because you're drawing it out. Okay. Use your scale to determine the dimensions of each piece of furniture. So this is 40 by 90, so that would be now 40 inches. We'd have to convert that to feet. So we would take out our calculator. We go 40 divided by 12 to give us feet. Okay, so that's 3.3, then we would divide by 2, so that would be 1.6 inches, and then we would go the 90, we divide that by 12 to find feet, and then divide it by 2 to find inches, 3.75. So we would go through and we could do that for each of these things, then we could cut them out on little pieces of paper or draw them in and find out where they fit. Okay, and that should be what they did here. So 1.7 by 3.75. Good, we did that correctly. And then you could decide where you wanted to put it based on what space there was. Okay? Maxine used a scale factor of 1 to 16 to create her diagram. Explain the advantages of using this scale factor. So what would be good if instead of 1 to 16 we did 1 to 24? Then we would be in 1/4 of an inch and it would be easy as opposed to some of the measurements we had. Okay? Does it make sense ever to have a scale factor to be less than 1? It makes sense because we are doing a reduction. So when we go from a room to a piece of paper, you're drawing everything smaller. So it should be a smaller factor. And that's what we're going to talk about here. Scale diagrams are used to represent 2D shapes. To create a scale diagram, you must determine an appropriate scale. This depends on the dimensions of the original shape and the size of the diagram that's required. The scale factor is the ratio of the distance measure of a shape to the distance of a similar shape, where both measurements are in the same unit. You can multiply any linear dimension of a shape by a scale factor to calculate the corresponding dimension of a similar shape. When determining the scale factor, the measurement is placed in the denominator, the diagram over the actual. So this is very important. K is equal to diagram over actual. When it's between 0 and 1, it's a reduction. When it's greater than 1, it is an enlargement. So enlargements come when you have a model. For instance, if I have a model car, the new shape is an enlargement. So if I used a model car to make a car, that would be an enlargement.